Good morning students, this is Vikas Global Institutions, Jangareddy. So last class in chemistry I will discuss about the thermodynamic first law. Thermodynamic first law. What is the formula of thermodynamic first law? That is the delta E Q plus W. Delta E is equal to Q plus W or delta U is equal to Q plus W. Anyone we write the delta E or delta U, Q plus W. This is thermodynamic first law. And later I was discussed about the applications of thermodynamic first law. So what is the thermodynamic first law? Energy neither created nor destroyed, but it is when converted into one form to another form. Okay, so that is the thermodynamic first law. It is a thermodynamic first law. It is the law of conservation of energy. Law of conservation of energy, or the total energy. The total energy of the isolated system is the constant, remains constant. That is one of the definition of the thermodynamic first law. Energy neither created nor destroyed, but it converts to one form into another form. It is a law of conservation of energy. The total energy of the isolated system remains constant. That is one of the thermodynamic first law. So we write the delta E is equal to Q plus W, and later I was discuss about the applications of the thermodynamic first law. One is the isothermal process. Isothermal process చెప్పుకున్నాం. Next one adiabatic process. Adiabatic process, and next one adiabatic process. Next one isobaric process. Next one isochoric process. Isochoric process, and last one cyclic process. Cyclic process. These are all last class applications of the thermodynamic first law. Okay, now I will discuss about the relation between the delta H and delta U. Okay, relation between delta H and between the delta H and delta U. Okay, Nana? Now we take the one chemical reaction, it involving the gases. Take the chemical reaction. We take the chemical reaction, it involving gases. Let us we take the VA, VB. So what is the VA? It is the total volume of reactants, and VB is the total volume of products. We consider one chemical reaction, it involving the gases. So we take the VA and VB. Here what is the VA? Total volume of the reactants, and VB is the total volume of products. And also we take the NA, So what is NA? What is NB? NA is the number of moles of gaseous reactants. And what is NB? Number of moles of gaseous products. Okay, so let us we take the VA, VB and NA, NB. So what are the VA, VB? What is the NA, NB? Okay, and next one, we know the ideal gas equation. What is ideal gas equation? PV is equal to nRT. We know the ideal gas equation. PV is equal to nRT. So applying the VA, VB, NA, in the ideal gas equation. Okay, we write the first one, we write the PVA is equal to nART. And next one, we write the PVB. PVB is equal to NBRT. From this is the 2, we take the 2, this is the 3. From 2 and 3, we write PVB minus PVA. We write PVB minus PVA. This is the total volume of the products minus volume of the reactants. PVB minus PVA is equal to NB RT minus NA RT. Okay, common of the P, we write the PVB minus VA equal to, here the common is the RT into NB minus NA. Here what is the VB VA? What is the NB NA? It is the volume of the total volume of the reactant products. Here the total volume of products and reactants. It is the change in the volume. VB minus VA means it is a change in the volume, and NB minus NA means change in the number of moles. We write the PV means P delta V equal to, P delta V is equal to RT into delta N gas. Delta N gas. P delta V is equal to RT delta N RT, or also we write the P delta V, also we write the P delta V is equal to delta N gases RT. We write the anyone. We write the anyone. So P delta V is equal to delta N RT. Okay. Now we take the enthalpy. What is enthalpy? H is equal to U plus PV. We know the enthalpy reaction. Enthalpy reaction. This is the enthalpy reaction from Clausius. From Clausius, enthalpy reaction is mathematically easy. The enthalpy mathematically it is expressed as H is equal to U plus PV. It is discovered by it is expressed by the Clausius. What is the enthalpy? What is enthalpy? We know the enthalpy. So that is the H is equal to U plus PV. It is a measurable amount of the substance. So that is the H is equal to U plus PV. So it is given by the Clausius. So at constant pressure, which we write the change in enthalpy, we write the change in enthalpy. So what is the change in enthalpy? Delta H is equal to delta U plus P delta V. Here the pressure is a constant. We write that at constant pressure, we write the change in enthalpy. We write the change in enthalpy at constant pressure. Change in enthalpy. Change in enthalpy. Change in enthalpy at constant pressure. Change in enthalpy at constant pressure, we write the delta H is equal to delta U plus P delta V. From equation 4, we write the change in enthalpy. So here the P delta V is equal to delta N RT. Here the formula is that delta H is equal to delta V plus P delta V. The P delta value from 4, the P delta value substitute in the equation 5. P delta value, P delta is substituted in equation 5. So now we get delta H is equal delta U plus P delta V means delta N gases RT. So this is the relation between the delta H and delta U or delta E. Anyone we write delta E or delta U. So we answer, for example, we write the delta H is equal to delta E plus delta N RT. Anyone we write. This is the relation between the delta H and delta U. Here the delta H is equal to the change in enthalpy is equal to change in internal energy plus change in number of moles into RT. Okay, Nana? So this is the relation between the delta H and delta E. Okay, here in case, here what is the delta N? Here what is the delta N? What is the delta N gas? Means number of moles of gaseous products minus number of moles of gaseous reactants. Number of moles of gaseous products minus number of moles of gaseous reactant. In case 1, in case delta N is equal to 0, then delta N is equal to 0 from equation 6 delta N is equal to 0 ayindi. So total is the 0. So we get delta N is equal to 0, then delta H is equal to delta U or delta E. Anyone we write, including sign. Even signs unte adi kuda include cheskondi, including sign. including sign. Okay, and next one, second case 2, delta n is greater than 0 అయింది, 0 కన్నా ఎక్కువ ఉంది. then delta h is equal to ఏమవుతున్నప్పుడు, delta h is equal to ఏమవుతుందనా, delta h is less than 0 అవుతుంది, less than 0 including delta h is less than delta u అవుతుంది, delta h is less than delta u or delta e including sign. And case 3 delta n is less than 0 అనుకుందాం, then delta h is greater than delta u or delta e including sign. This is the total relation between the delta h and delta u. Okay, once again I will repeat it. We take the chemical reaction, it involving the gases. Chemical reaction, we consider the chemical reaction, it involving the gases. Here the VA, let we take the VA, VB and NA, NB. What is the VA, VB? Is the total volume of the reactants and products. And NA, NB means number of moles of gases reactants and number of moles of gases products. We know the ideal gas equation. What is the ideal gas equation? PV is equal to nRT. This is the ideal gas. This is the ideal gas equation. PV is equal to nRT. That is given equation 1. So we write the PV is equal to nRT in terms of VA, VB, NA, NB. So we write the PVA is equal to NART. Here VA is the number of moles of total volume of the reactants, NA is the number of moles of gases products, gases and reactants, and PVB is equal to NBRT. Okay, from equation 2 and 3 we write the PVB minus PVA is equal to NBRT minus NART. Okay, and next one, P into VB minus VB, here P common, that P into VB minus VA is equal to RT into NB minus NA. Okay, and next one, it is a total volume change, it is the number of change in the number of moles of reactant products. So we write the P, VB minus VA is equal to delta V, change in the volume. So P delta V is equal to RT into number of change in the number of moles. So RT into delta N gaseous molecules. So also we write the P delta V is equal to delta N RT. It is the equation given 4. We know the enthalpy, that is that H is equal to U plus PV or H is equal to E plus PV. Anyone we write. H is equal to U plus PV enthalpy. Okay. We write the change in enthalpy at constant pressure. At constant pressure దగ్గర enthalpy లో change రాస్తున్నాం. So delta H is equal to delta U plus P delta V. That equation 5. And next one, P delta V is a substitute in the equation 5. Here what is the P delta V? This is the P delta V. That equation 4 substitute in the equation 5. So we write that delta P delta V substitute in the equation 5. So delta H is equal to delta U plus P delta V is the delta N RT. So P delta H is equal to delta U plus delta N RT. That equation given 6. Here the delta N gas means number of moles of gases products minus number of moles of gases reactants. So in case 1, delta N is equal to 0, and here delta N is equal to 0, total is a 0, so delta H is equal to delta U. Delta H is equal to 0, so delta H is equal to delta U or delta E including sign. In case delta N is greater than 0, then delta H is less than delta U or delta E including sign. In case delta N is less than 0, then delta H is greater than delta U or delta E including sign. This is the total relation between the delta E and delta H. So next one, I will explain one sum in the relation between the delta H and delta E. What is the relation? That is the delta H is equal to delta U plus nRT. Delta N gases RT. This is the relation of the delta H and delta U or delta E. So one problem on the relation of the H and delta H and delta U. ఒక ప్రాబ్లం చేద్దాం ఈ రిలేషన్స్లో. So here sum is, if water vapor is If water vapor is assumed to be a perfect gas, assumed to be a perfect gas, assumed to be perfect gas, molar enthalpy change for molar enthalpy change for vaporization of 1 mole of water, 1 mole of water at 1 bar and 100 degrees centigrade is 41 kilojoules per mole. Calculate the internal energy. Calculate the internal energy when number 1 case 1 1 mole of water is vaporized. 1 mole of water is vaporized at 1 bar and 100 degrees centigrade. This is the case 1. And case 2 1 mole of liquid 1 mole of water liquid, 1 mole of water liquid is converted into ice. Okay, చూడండి అన్న క్వశ్చన్ ఒకసారి. If water vapor is assumed to be a perfect gas, that is the most important point, perfect gas. ఇక్కడ ఏమంటున్నాడు, వాటర్ వేపర్ని ఒక పర్ఫెక్ట్ గ్యాస్ కింద తీసుకుంటున్నాడు. మనం పర్ఫెక్ట్ గ్యాస్ తీసుకున్నప్పుడు వాటి రిలేషన్స్ తీసుకురావచ్చు. దట్ ఇస్ డెల్టా హెచ్ డెల్టా యు. వై వి టేక్ ద కెమికల్ రియాక్షన్ ఇన్ కన్సిడర్ యాజ్ గ్యాసెస్ అన్నాం ఫస్ట్ వన్. సో ఇఫ్ వాటర్ వేపర్ ఈజ్ అస్యూమ్డ్ టు బి ఏ పర్ఫెక్ట్ గ్యాస్, molar enthalpy change for vaporization of 1 mole of water at 1 bar and 100 degree centigrade is, so enthalpy change ఎంత అంటున్నాడు ఇక్కడ 41 kilojoules per mole. Here the enthalpy change is 41 kilojoules per mole at 1 mole of water at 1 bar and 100 degree centigrade. And calculate the internal energy when ఇక్కడ. సో ఇక్కడ ఏమి చూడండి అన్న, case 1 is 1 mole of water is vaporized at 1 bar. 1 mole of water is vaporized at 1 bar and 1 mole of water is liquid is converted into ice. So first one we calculate the number 1 and next later we discuss the case 2. First one, here we give what is the given data, delta H ఇచ్చాడు ఎంత, molar enthalpy change for vaporization of 1 mole of water at 1 bar and 100 degree centigrade is del 41 kilojoules mole. So delta H is the given data, given is delta H is equal to 41 kilojoules per mole. You find out internal energy delta U. The change in enthalpy, what is the 41 kilojoules per mole? We calculate the delta U. In the case 1, what is the case 1? 1 is the 1 mole of water is vaporized, 1 mole and is equal to entapudu N1 means number of moles of water enta avutundana 1, that is vaporized at 1 bar and 100 degree centigrade. So case 1 is a H2O liquid is converted to H2O vapor means H2O gas. That is the case 1. 1 mole of water is vaporized at 1 bar, so means liquid water is converted into vaporized, that is a gas. Okay, based on this equation we find out the delta N gas. Here the number of moles of gas products in 1, number of moles of reactants in even unnaya, no. Why? This is a H2O liquid. but the total relation in the delta H and delta E is the only applying in the gases. So అందుకే మన క్వశ్చన్ ఏమి ఇచ్చారు, if water is vapor is assumed to be a perfect gas. Here the relation is the relation between delta H and delta E applying only in the perfect gases. So here the given is the delta H enthalpy change is 41. We find out internal energy. In the case 1 mole of water is vaporized. Vaporized means gases. That means liquid is converted into gases. H2O liquid and H2O gas. With the number of moles of products in this is the reactant, this is the product. Reactant is the one, but it is a liquid, and H2O is the gas, and product is the gas. So number of moles of product is the 1. If we know the delta N products minus delta N reactants. So we get the 1 minus 0, that is equal to 1. So delta N is equal to 1. Clear Nana? So how we get that the delta N is the number of moles of products, number of moles of gases product minus number of moles of gases reactants. But here the only gases products are there. There is no gases reactant. So delta N number of moles of products, number of moles of gases product is the 1, number of moles of gases reactant is the 0. So delta N is equal to 1. Okay, we know the R value. What is R value? That is R is equal to 8.314 into 10 to the power of minus 3 joules Kelvin small inverse. And also we know the T value here. The 1 mole of water is vaporized at 1 bar and 100 degrees centigrade. So 100 plus 273 Kelvin. So that is equal to 373 Kelvin. Okay. Here the delta H is there, delta N is there, R is there, T is there, T there. So substitute the formula. What is the formula relation in the delta H is equal to delta U plus nRT. Sorry, delta nRT. Substitute the total values. What is the total value? Delta H is the 41 kilojoules per mole, and delta U we find out, and delta N is equal to 1, and R is the 8.314 into 10 power minus 3 into T is the 373 Kelvin. And finally we get the delta U is equal to 37.9 kilojoules per mole. Calculate the total value. The 41 ఇటు వైపు తీసుకెళ్ళండి అన్న, డెల్టా యూ తీసుకురండి. Total calculation is the delta U is equal to 37.9 kilojoules per mole. This is the case 1. 1 mole of water is vaporized at 1 bar 100 degree centigrade. The internal energy is the 37.9 kilojoules per mole. That is the case 1. And case 2. What is the case 2? Here 1 mole of water is liquid is converted into ice. Means H2O liquid is converted into H2O ice means solid. Okay, clear. Here anyone gas molecule? No. Why? Here the H2O reactant is a liquid, H2O product is the solid. There is no gases. So delta N is equal to delta N is equal to 0. Delta N is equal to 0. So in case 1, we know the relation between the delta H and delta E low. Delta N is equal to 0. We get the delta H is equal to delta U. So what is here? The delta H, you know the delta H value, that is the 41 kilojoules per mole. And also delta U is equal to 41 kilojoules per mole. In the case 1, internal energy is the delta U is equal to 37.9. In the case 2, delta U is equal to delta H. So delta U is equal to 41 kilojoules per mole. Clear Nana? Clear. The case 1 you find out internal energy, and case 2 you find out the internal energy. But here in the case 2 there is no gaseous molecule, so delta N is equal to 0. So delta H is equal to delta U. So here the delta H is 41 kilojoules per, that is the given one, that is the delta N is equal to H is equal to 41 kilojoules per mole. So also we write delta is equal to 41 kilojoules per mole. Clear Nana? So we applying in the relation in the delta H and delta applying only in the gaseous molecules. In the first case, there is one gas molecule is there, we find out the delta n, that is equal to 1, R value is there, T is there, substitute the values, that is we get the delta n, delta U, internal energy 37.9. In the case there is no gaseous molecule, so delta n is equal to 0, so finally we get the delta U 41 kilojoules per mole. This is the today class. So today class is the relation between the delta H and delta U, and case 1, 2, 3. And next one problem on the relation of the delta H and delta U. Okay, Nana? Thank you, students. Tomorrow I will continue. Thank you.